Hi everyone, and welcome! Today we are tackling a common electronics challenge, modifying an AC current switch. Many off-the-shelf AC current switches are designed to turn on at a specific current, perhaps 50 milliamps. But what if your project needs it to activate at a much lower current, say 20 milliamps? We're going to explore how you can adjust that trigger point, making your switch more sensitive to smaller current flows. This can be super useful for monitoring low-power devices or detecting subtle changes in an AC circuit. First, a very important safety warning: we are dealing with AC mains voltage here. This can be dangerous and even lethal. Always unplug the device from the wall before opening it or making any modifications. If you are not comfortable working with AC power, please do not attempt this modification. Seek help from someone experienced. Your safety is paramount. Now, let's understand how these switches generally work. Most AC current switches use a small current transformer, CT, to non-invasively sense the current flowing through a wire. This CT converts the AC current into a smaller, proportional AC voltage. This AC voltage is then typically rectified into a DC voltage. This DC voltage is then fed into a comparator circuit. The comparator compares this sensed DC voltage against a preset reference voltage. When the sensed voltage exceeds the reference voltage, the comparator triggers, and the switch turns on. To change the trigger point from 50 mA to 20 mA, we need to make the comparator trigger at a lower sensed voltage, because 20 mA will produce a smaller sensed voltage than 50 mA. This means we need to make the circuit more sensitive to the CT's output. Here's how you can likely achieve this modification. You will need a few basic tools: a small screwdriver set to open the switch casing, a soldering iron, some solder, a multimeter, and a selection of small resistors, possibly including a small potentiometer for testing. 1. Open the casing. Carefully open your AC current switch. Look for the main circuit board. 2. Identify the sensing circuit. You'll typically see the current transformer, which is often a small toroid, donut-shaped, coil, or a black block with a hole for the wire. Follow the wires from the CT to the circuit board. This path leads to the sensing and comparator circuit. 3. Locate the threshold setting component. Somewhere in this sensing path, or near the comparator integrated circuit, IC, there will be components that set the trigger threshold. This is often a fixed resistor or a small potentiometer, a variable resistor. If it's a fixed resistor, it's usually part of a voltage divider that feeds the comparator or sets its reference. 4. Determine the adjustment. To make the switch more sensitive, trigger at a lower current like 20 mA instead of 50 mA. You generally need to increase the resistance value of a resistor that scales the CT output, or decrease the resistance in a voltage divider that sets the comparator's reference voltage. Without a specific schematic, it's hard to give an exact resistor value, but the principle is to adjust the voltage level that the comparator sees. If you find a potentiometer, try carefully adjusting it with a small screwdriver while monitoring the output, after reassembling safely and applying power to test, of course. 5. Calculate or estimate a new resistor. If there's a fixed resistor, and you know the original trigger current, 50 mA, and your desired current, 20 mA, the ratio is 50 divided by 20 is equal to 2.5. This means your circuit needs to be 2.5 times more sensitive. If the resistor is in series with the CT output to a comparator, you might need to increase its value by roughly 2.5 times. If it's part of a voltage divider setting the reference, you might need to decrease a specific resistor's value. A good strategy is to temporarily solder in a small potentiometer, e.g., 10K or 20K ohm, in place of the suspected fixed resistor. You can then adjust the potentiometer until the switch triggers at your desired 20 mA. Once you find the correct resistance value with the potentiometer, measure it, and replace it with a fixed resistor of that value. 6. Test thoroughly. After making the change, carefully reassemble the switch, ensuring no bare wires touch the casing or other components. Connect it to your AC source with a known load that draws exactly 20 mA or slightly above for testing. Use your multimeter to verify the current draw. The switch should now turn on reliably at 20 mA. Thank you so much for watching this video. I hope this guide helps you customize your AC current switches for your specific project needs. If you found this information useful, please consider giving this video a thumbs up, And don't forget to subscribe to the channel for more electronics tips and tutorials. Your support helps us create more content like this.